Hi everyone. In this short video, we're going to go over our atmosphere and we're going to talk about radical mechanisms that occur in the atmosphere. So let's start with a molecule called ozone. So ozone is made up of three oxygens and it forms what we call a layer in the stratosphere. Now, what's great about ozone is it shields us from harmful ultraviolet rays or UV rays. So if you've ever gotten a really bad sunburn, you likely were exposed to UV rays for too long. And unfortunately, if you are, let's say, somebody who tans a lot or is outside a lot, when you get older, that can have negative effects. It could even lead to, for instance, skin cancer. So it's always good to go to a dermatologist when you get older, just to make sure. All right, so how does ozone shield us from these harmful UV rays? Well, let's look at the mechanism here. So ozone, when it interacts with UV rays, which are, of course, light, it breaks apart into an oxygen molecule and an oxygen atom. And then the oxygen molecule and the oxygen atom are going to reform ozone and produce some heat. So ozone is absorbing the UV rays and then breaking apart as a result. And then ozone will reform, and then we'll also have some heat there as well. Now, unfortunately, over the years, the ozone layer has been depleted due to many different molecules, but the main culprit were a class of molecules called chlorofluorocarbons, or CFCs. So let's just make a note. The ozone layer has been depleted due to chlorofluorocarbons. And these are really simple molecules, but they have such a negative effect on ozone. Now, chlorofluorocarbons are compounds that only contain carbon, chlorine, and fluorine. And in the past, they were used in refrigerants, propellants, and foam insulation. But nobody really realized the effect that they were having on our atmosphere until the early 1970s. And three scientists named Mario Molina, Frank Rowland, and Paul Crutzen, I think is how you pronounce that. Um, they did a lot of research on the ozone layer, and they found that these CFCs were depleting it. And they actually share the 1995 Nobel Prize in Chemistry for this discovery. Now, CFCs are stable until they reach the stratosphere. Once they reach the stratosphere, then they interact with those UV rays and they go through the following radical mechanism. So in the initiation step, let's draw a chlorofluorocarbon. And when it interacts with light, It goes through homolytic cleavage, where one of the chlorine atoms is going to leave as a radical. All right, now in the propagation steps, well, I hope I left myself enough room. I tend to not leave myself enough room. So in the propagation steps, chlorine, that chlorine radical is going to interact with ozone. And we form the following. So chlorine takes an oxygen from ozone, and then an oxygen molecule is left behind. And notice that the chlorine and oxygen molecule there is actually a radical, so there's a single electron hanging out. And then in the next step, the chlorine oxygen molecule there is going to react with an oxygen atom that's been produced from ozone and form oxygen, the oxygen molecule, and another chlorine radical. So the chlorine radical is actually regenerated here. So because we're regenerating that chlorine radical, this reaction will keep occurring. So it's a chain reaction. So that chlorine radical can go on to break down more ozone. And then this is what's preventing ozone from reforming. So we end up losing or depleting ozone in the atmosphere. So this is a really dangerous molecule for us because with more UV rays, there's more exposure to potentially skin cancer, etc. Now, the discovery of these CFC molecules depleting the ozone layer was a good thing because we ended up forming a global treaty called the Montreal Protocol in about the 1980s. And everyone agreed, we really need to reduce the production of these CFC molecules. So they found alternatives that wouldn't break down ozone. So the concentration of chlorofluorocarbons has really been decreasing since the 90s, and we're starting to see the ozone layer kind of repairing itself, which is awesome. Now, unfortunately, chlorofluorocarbons have a really long lifespan, so it's going to take a while to completely repair the ozone layer hole. But we're kind of on the right track here. Another good thing is actually over the last year, because everybody has been isolating due to the pandemic, there's been reports that the level of pollution and smog, etc., has really gone down. They said potentially by about 10%. So that could have some positive effects as well on our atmosphere. Now, of course, the pandemic has been awful, so I don't know if that's necessarily a good thing, but, trying to look for the positives here. So anyway, I just wanted to kind of show you an application of these radical mechanisms. Your textbook goes into more detail on all of this, so if you are really interested in radical chemistry, feel free to read through those sections. In the next video, we're going to talk about another type of radical reaction called radical polymerization. So if you've heard of polymers before, we're going to talk about those next time. So I will see you then.